interim treatment was abolished by the initiatives and evidences created by our center. This abolished the sanitary mode of treatment and brought the home-based treatment for TB patients. One of the largest BCG trial ever conducted in the world is BCG vaccine trial, and it was conducted by NART and brought about the efficacy of this BCG vaccine. And it said that it is totally gives 0% protection for Indian adult population. But whereas the European strains of BCG vaccine gave a protection of about 70%, but for the Indian population, among the adult population, BCG gave just 0% protection. This was one of the major landmark paper, another landmark paper. Apart from this, our strength is conducting clinical trials. So far, we have conducted around 50 randomized controlled clinical trials in TB, including pulmonary as well as extrapulmonary, as well as HIV TB co-infected patients also. The major other initiative was to provide the evidence base for globally administering this DOT strategy. DOT strategy is now being followed for providing treatment for TB patient, which is just providing the tablets to the patient under supervision. The evidence for this necessity was created by NART through several research, and this was the first it provided this NART center provided the nation's first reliable estimate of TB burden for the entire country, as well as now it is being conducted in phased mode manner after 10 years. The new TB prevalence study has been carried out in large scale. Now it has been undertaken for the entire country. It has been coordinated by NART, and it has conducted two HIV preventive vaccine trials, and it actually provides NART provides regular manpower guidance as well as technical support to Central TB Division, which caters to the RNTCP, Revised National TB Control Program of India, Government of India. We actually are one of the main partners for providing manpower guidance as well as technical inputs to this program for Central TB Division. And multi-center cohort study on relapse of TB patients is under the initiative by RNTCP, and it has been recently completed.
Okay.
So these are the important activities by NART, and I belong to a department called bacteriology. I am basically a bacteriologist handling TB cultures
Okay.
and
Okay.
related research related to this TB bacteria. So it is, as I said, it's caused by a
Ah,
bacteria called Microbacterium tuberculosis, and these are the main research for areas where I worked
chalo.
recently for the past 10 years.
Okay. Okay.
The total number of my experience in this center is around 22 years, and microbacteriophages is one of the main cup of tea for me in my research. Microbacteriophages are viruses basically which can infect this bug, Microbacterium tuberculosis. So my team use this microbacteriophages to bring out rapid diagnostic methods for diagnosing TB, as well as the use of this viruses for TB treatment as well. This is under research, and we have developed AR into process and initiatives for developing innovative and rapid diagnostic tool for TB. The other main area I'm working in is called as a resuscitation promoting factor. These are interesting factors produced by young laboratory cultures of this MTB, and which can or has the capability of regrowing the dormant bacteria. This dormancy, or otherwise it's called latency, is another interesting and unknown area. A lot of research is still needed in this latency work related to TB. I'll be talking about this one in due course of my slides. And discovery of a new anti-TB molecule is another area I'm working in from different ecosystems. We receive molecules and compounds from the other centers also. We do validate them for the efficacy against TB in our lab. So directly, I want to jump into this tuberculosis disease. Uh, this is a slide which depicts the due course of the possible outcomes if a person is exposed to this bacteria. As we all know that TB is endemic in India, like COVID is pandemic for the entire world. TB is endemic in India, and when a person is exposed to a bacteria which has been coughed out by a patient, TB infected patient, so upon exposure, 70% of the people doesn't get the infection, but they'll be exposed. They would have inhaled the bacteria, but the disease would not have progressed to tuberculosis. So they'll be actually being contained by their immune system, or sometimes it would have been harbored or lodged inside any of the organs of the person, and this lodging of this bacteria leads to the dormancy. So this is still there are a lot of mysteries surrounded by this possible evidence of creating dormancy of the persons who are exposed to this infection. So in 30% of the people, the infection leads to the development of the disease, tuberculosis. So among this 30%, still 40% only leads to produce primary active TB, and less of the 60% produce to harbor the leads continue to harbor this bacteria in them throughout the lifetime. Among the 60%, which are called as latent population, uh, they may or might continue to harbor the bacteria till they die. Among them, 2 to 33% of them per lifetime will end up in reactivation TB, producing to produce a full blown blood TB infection. And among them, some of the persons who are, if they are going to be infected with HIV, there will be the reactivation of this TB can occur at the rate of 5 to 10% per year among this HIV infected people. They are much more vulnerable to getting this infection with TB. So this is the possible outcomes upon exposure. So still there are a lot of research has to be done among what is happening in this latent TB and what are the stress factors among this latently infected people to get reactivated during their lifetime, and what is the contributing factor for this reactivation. What are the stress factors making the bacteria to reactivate among this latent population? Where are these bacteria going to getting harbored into the in the patient is still a holy grail. Still, a lot of research is being done in this latent TB population. So only in the other 40% primary TB patient, only this 40% of the people are being diagnosed by the existing currently available techniques. So I'll be talking about what are the techniques available and which are recommended by WHO and which are in the pipeline. So, TB diagnosis, this is our cup of tea, and early diagnosis is the key factor for TB eradication and management. And the common methods for TB diagnosis can be divided as phenotypic based assays as well as genotypic based assays. Among the phenotypic based assays, here physically we are going to uh, uh, define or demonstrate the presence of this bacteria to call the person that is infected with TB. So one of the simplest technique, rapid technique, is the demonstration of acid fast and fluorescent microscopy. So this is actually a robust, simple technique, but I'll be talking about this individual assays in the next slides. And the other one is the solid culture by LG methods or Ugava method in other countries, liquid culture. Among the genotypic assays, Gene Expert, Line Probe assay, and TrueNAT assays are the latest approved method by the WHO. So regarding the phenotypic assay, the acid fast and the fluorescent microscopy, the overall clinical sensitivity of this method is 22 to 80% depending on the burden of TB. The type of AB stain used and the experience of the laboratory technician is a must for demonstrating the bacteria under a microscope. It hardly takes around 30 minutes to demonstrate, but the sensitivity of the assay is like it requires around 10,000 bacilli per ml of the specimen for it to be identified under a microscope. So until it reaches a load of 20,000 bacilli, this bacteria cannot be diagnosed by use of this acid fast technique. So there are a lot of complexities in diagnosing. So I'll be enumerating in the few slides, subsequent slides, and what
Okay.
and things how we can address also. And the one is the fluorescent
Certificate.
microscopy. You can see in the slide the golden colored rod, kind of bacilli appearing in this second picture in the slide. This is been detected by a microscope, lead FM microscopy, and it has a pooled sensitivity of 66% and a pooled
Slide clear
sensitivity
sir.
of 96%.
Slide check பண்ணுங்க.
So, very
Slide
less
not clear.
specificity is there associated with this acid fast staining method, but it is the rapid as well as the cheapest method for demonstrating the presence of the bacteria.
Slide clicker.
If it is positive, straight the clinician can initiate the treatment by use of this method, but yet the sensitivity is very low when compared to the other methods. So until then, the patient would not be diagnosed by this method, and he'll keep on spreading the bacilli in the community. So, what are the other more sensitive methods? Is culture-based assays. So, culture-based assays we use solid as well as liquid Solid is little bit time consuming. It takes around 8 weeks for the appearance of the bacteria in a nutritive, sufficient, and luxurious containing media. So this bacteria bug is a very adamant one. It requires a very special kind of nutrition, proteinaceous media like egg-based media for them to survive and multiply in this artificial media in the lab. So, but it is very lazy also. Its generation time is around 20 hours when compared to the other bacteria which causes pneumonia or diarrhea, like Streptococcus pneumonia or the one causing cholera. Their generation time is just 20 minutes. So the next day you can see the colonies. But for this TB bacteria, it takes around 8 weeks because its generation time is in hours. So that's why it is very slow method. But the sensitivity is around 100 to 100,000 bacilli can be detected from each ml of the specimen. So comparatively lower sensitivity but equal specificity with the in terms of when you compare it with the liquid culture based assays. It requires a separate testing for finding out whether the bacteria are responding to a particular drug or not. The drug sensitivity assay. It requires a separate testing. As a future perspective, we are working to increase this sensitivity by incorporating the use of this resuscitation promoting factor, I said earlier in my slides, to increase the sensitivity. So this one we have just came out with a come out with a publication just appeared recently in Frontiers Microbiology in the last year, end of the last year. So here we had demonstrated the use of RPF to increase the sensitivity and to regrow those adamant ones which does not grow in the existing culture methods. So this is the potential of this RPF protein. We are into this one to bring out this assay incorporating into the existing culture-based assays. The next most sensitive assay is the liquid culture, and it has some very good advantages as well as demerits. Liquid-based assay requires an automated estimation, and this comes along with the cost of around 20 to 30 lakhs. And it's a closed system, assay system. That means we need to purchase the reagents from the this company in the manufacturer. So it actually detects the presence of this bacteria by the change in the fluorescent quenching present in the media containing tubes, and this is detected by the machine continuously on agitation, and it gives us as positive. And so there is not much of uh, physical activity is required for growing this bacteria. This machine has around 3 shells, as you see in one of the photo. One of the shelf is been extended out, pulled out, and so each of the mission can cater around 960 culture samples. So that's why it is called as midget 960, and its sensitivity is very high when compared to solid cultures. But again, it is a little bit slow. But in compared to solid culture, it's a little bit rapid. Here, around it takes around 10 to 12 or 14 days for terming out, terming the patient is suffering from TB or not. That is why it's not that rapid. It takes at least lesser than 2 weeks for diagnosis for diagnosing TB. So, what are the other rapid methods? We have, in fact, we have molecular-based assays which can detect TB in less than 3 hours. So, this is one of the earliest mission approved by WHO called Gene Expert. It is a genome-based method, and a Gene Expert system is a semi-automated, real-time PCR method amplification technology where the gene of interest, particular sequence, short stretch of the genome is been amplified by RT-PCR, which can simultaneously detect the presence of bacteria as well as it can detect rifampicin resistance also. This is one of the core drug for treating TB at present. A drug-sensitive TB can be treated by use of this rifampicin, where we can find out whether this bug is resistant to or responding to this rifampicin or not. That can be done by this mission, and it has a sensitivity of 100% in positive cases, so suitable for all the samples except blood. But it for per test it costs around 1,400 rupees, and so it's a little bit expensive. Comparatively, it does not require a very well equipped lab. General BSL-2 facility or BSL-1 facility is sufficient for running this equipment, but it can detect only the DNA. So this DNA can come from the dead bacilli as well. So that is the main drawback of this one. So for treatment improving monitoring, this machine is not good, but initial time of detection is very less. So less than 3 hours you can detect and start the treatment. You need not wait for the bacteria to grow. So that is the main advantage of this gene expert. So this was approved and it's been by WHO and it's been followed in most of the TB labs in the world. The next one is the indigenously developed TrueNut assay. It's a chip-based real-time PCR method. It also the same principle works in the same principle of the gene expert. This can quantitatively detect MTB, and it has two units: one for the DNA extraction and another one for running the amplification. So this was recently approved by WHO. What are the pros and cons? It's very handy and battery operated, and it's one of the best point of care testing method, more economical than the gene expert. It is the first emission approved by the WHO from India. And what are the cons? Does it requires extraction of DNA before amplifying and reading out the results? Unlike gene expert, it requires a separate test for to run the rifampicin drug susceptibility. So these are the two assays which can be used for COVID also. So it has been in use for in several countries for adapting it for COVID diagnosis also as well. So these are the two important assays which have been approved by WHO. And what are the other diagnostic methods in the pipeline? Is one of our own technique is called luciferase reporter phage. And this is the diagrammatic representation of this principle of this assay. This has been developed by Albert Einstein College of Medicine, New York, as well as we had partnered with them earlier in bringing out the viral constructs, and we are still carrying it out here in our lab to bring it as a point of care testing device. So this is operates on this simple principle, like we have constructed the virus which can specifically infect Mycobacterium tuberculosis. We have a genetically engineered gene from this firefly. It is called as FFlex or luciferase gene. We have chopped out that luciferase gene from firefly and genetically engineered into the genome of this virus, which can infect specifically Mycobacterium tuberculosis. So upon infecting tuberculosis bacteria, this virus injects its DNA carrying that luciferase acid, and upon entering this genome, it's entering after entering into the live bacteria of TB, it produces multiple copies of this virus. And during the course of developing, producing the multiple copies of this virus, this enzyme luciferase is secreted, and this, in the presence of a substrate, it produces photons, and this can be measured by using of a simple laboratory luminometer. So, upon photon emission, we can say that Mycobacterium tuberculosis live cell of this bacteria is present in the specimen. So, recently we have several publications for use of this technique for identifying the bacterial susceptibility by use of this LRP for diagnosing. Still, it has lower sensitivity. We are working on it. What are the other assays? Is the other main assay is LAMP assay. It's a loop mediated isothermal amplification, and WHO suggests that LAMP as a replacement of for sputum smear microscopy in fresh and follow-up cases. So here, this LAMP assay can be the readout can be detected by use of a UV simple UV lamp, or as well by visual method also. So the readout is very simple and can be done in every other diagnostic laboratory facilities. The other major assay is MOTS. It is the microscopic observation for drug susceptibility assay. It's one of the rapid and economical, highly sensitive and specific method for detection of TB and drug sensitivity directly from sputum samples. So this has been followed in some of the countries, which is it is approved by their government. Still, it's an the marketed version is not still available, which can be approved by WHO. So these are the assays for under the pipeline for diagnosing TB. So next, and there's a couple of slides I'll be talking about the epidemiology of tuberculosis, as well as the treatment modalities and management aspects, and what are the program related to issues related to management of this TB will be dealt in this following slides. So TB is completely treatable and curable, but yet they are a deadly disease, causes a lot of fatalities in the world. It has imposed a serious threat and burden to global public health, and there are basic complexities involved in its diagnosis and the time lapse between the diagnosis, treatment, and the completion of treatment. Because the course of treatment requires around a month, the duration of 6 months if they are going to be drug sensitive, isolates which are infected the patient. It requires a multiple therapy of 4 drugs for a period of 6 months. These are the frontline drugs like isoniazid, rifampicin, ethambutol, and pyrazinamide are being given for curing this infection in the patient if they are going to be drug sensitive. But this regimen is futile against drug resistant strains. So for if they are the strain is in the infecting strain is going to be drug resistant, it requires much more advanced antibiotics, which are having more of side effects, and it requires a more lengthy period of treatment duration. So these are main aspects, showing worrying aspects in treating the patients. And this bacteria can infect ultimately any part of the body except our hair and lips. So nails, hair and nails. So, but recently nails also, the bacteria could be the presence of this bacteria could be detected in nails also. So basically, it can infect any part of the body, any organ of the body. But primary infection is through lungs, and so it lodges in our lungs, causing tuberculosis, pulmonary tuberculosis. It stays in our alveolus and may remain dormant throughout the lifetime and getting reactivated also due to different stress factors. If the patient is immunocompetent, this bacteria gets reactivated as soon as the person is immunosuppressed. The cell wall is much more thick, and it has a very thicker peptidoglycan layer full of lipids. This actually prevents, makes acts as a barrier for multiple drug targets, which is present in underneath the bacteria cell wall, and so this prevents the major drugs to reach the multiple targets to kill them. So that's why we use a regimen of 4 drugs. One drug actually loosens up the cell wall, this thick cell wall, so that the other bacteria drugs can enter the cell wall and act upon the RNA polymerase and other primary targets, so that to kill the bacteria and eradicate from the human system. So that's why multiple therapy is required due to the complex cell wall nature, and this is one of the major issues in treating TB. This slide actually shows the drug-resistant TB spread among the entire world. India is one of the endemic, and you can see around 1.5 lakh drug-resistant cases are reported in India alone. So this shows the picture of the drug-resistant TB prevalent in other countries in the world. So, what are the main hurdles faced in when you call eradication of TB? So, defaulting, patient actually is required to take the drugs for a period of around 6 months. So there are, and the pill load is heavy pill load, around 4 drugs he has to take at a stretch every alternate days. So this pill load is a very worrying aspect for the patient, for patient to take up, as well as so this pill load as well as the adverse reaction side effects associated while taking consuming these tablets is much more for the patient to bear during the treatment. So this contributes to the discontinuity of the treatment due to side effects, and the length of the treatment is also another issue. It requires around 6 months. If it's going to be drug resistant, it might require a duration of 9 to 12 months if it is going to be drug resistant. Another issue is poverty and the patient's lack of motivation. These are the main issues, hurdles faced in eradication of the TB. So this leads to the discontinuity due to the side effects or the pill load or the length of treatment. These are the effects causing to, the patient to default, and this leads to the emergence of drug resistance. So, what are the other main risk factors for the TB cases which are attributable for TB cases in India? Yes, HIV. If the patient is HIV, if the patient is having diabetes, smoking, harmful effect of use of alcohol, and if they are going to be undernourished. So these are the main risk factors which are influencing the number of TB cases in 2018. And what are the indicators in the Sustainable Development Goals associated in TB incidents? Are these two slides depicts the indicators like HIV prevalence, the TB, diabetes, HIV, TB, and TB diabetic co-infection comorbidity. You can see in this slide from 2000 to 2017, the number of diabetic patients are getting increased, and the use of alcohol is actually around for the age of more than 15 years could be seen in this slide. The other one, the main indicator is the prevalence of undernourishment and population covered by social protection. This slide shows the other, the graph shows the population covered by social protection in terms of percentage, but it is seems to be ideal in the same level from the year 2000 to 2017, except the people living with poverty is slightly in a decline phase from 2000 to 2017. What are the other indicators is smoking. It's little bit coming down from 2000 to 2017, and the other important indicators is universal health coverage is little bit in the upper trend from 2000 to 2017. But the other one is the Gini. The important indicator is Gini index. This is actually a score for determining if there is perfect equality or totally inequality among the income of every other persons in the population. A score of zero is totally reflects the perfect equality, and 100% is perfect inequality exists in the among the persons in a country. For giving an in a example for Gini in the US, it is around 47. So there is little bit of inequality, and when you compare to India, it is around 33. Lowest is around 24 in it is in some other northeastern countries of the world. So this Gini index is also remains on a stable in India from 2000 to 2017. Remains that still there is inequality among the resources and income among the patients. So these are the important indicators for sustainable goals which are required for in associated with TB incidents in India. So, what are the guidelines stressed upon by WHO for management of this TB? Is this slides depicts the main guidelines and strategy adapted by WHO. This NPV is the currently accepted motto, advised motto adapted by WHO, which has an ambitious target of achieving its feat of eradicating tuberculosis in global scale by 2030. So it has put a timeline of 2000, deadline of 2030 for creating a situation called NTB. This can be achieved, conceptualized by through these three of the major policies which is advocated by WHO. One is patient care, bold policies by the government, and research and innovation. So, what is NTV strategy is like we need to have at least 80% drop in the new cases by 2030, and 90% drop should be there in the mortality due to TB by 2030, and there should be an 100% drop in the poverty. So these are the main achievement indicators which can tell the world that TB is eradicated from the world. So these are the main achievable indicators towards which WHO has conceptualized and advising the entire country in the world to move towards this goal by 2030. So what is the Indian roadmap in combating this tuberculosis, multi-drug resistant and drug resistant TB? This gives an approximate stats of TB reported in India. A national estimate of 2.76 million cases is reported in India by WHO. The incidence of drug resistant, multi-drug resistant TB is estimated to be around 1.4 lakhs, 1.4 lakhs, nearing to 1.5 lakhs. And India, in fact, records the highest share of drug resistant cases. Around 24% of the global burden of drug resistant cases is reported in India. It's seen in India. This is a major worrying factor, and India has set a strong resolution in ending this TB and making it as a TB free nation. In fact, our Prime Minister in 2018 has kick-started a campaign, NTB campaign, and urged the government and private sectors to show a high-level commitment to attain this goal by 2025 itself, 5 years before WHO's thing, WHO's advice. So Indian response to this NTB is been mainly catered by Central TB Division. The National TB Control was launched by this Central TB Division, the Government of India, in 1962, and had functioned nearly 50 years. And the Ministry of Health and Family Welfare has recently launched as a this control program strategy as revised national TB control with the vision of TB-free India, and now with the vision of TB NTB strategy, this RNTCB has been converted, revised as National TB Elimination Program, and they have strategized to achieve this goal by 2025. So, to end my talk, these are the important pillars by which we can see that TB is eradicated from India, to detect the TB at an earliest time point, to treat them, prevent them, and to build the strength workforce. So detectors to notify the TB cases. The Indian government has launched a web-based surveillance system called NICSHI, where each and every TB patient positive is being entered into this software. Even the private sector, the clinicians are also mandated to enter the information of the TB patient in this NICSHI software, and the government of India has encouraged the public-private partnership, and is providing the drugs entirely free of cost, and diagnostic facility also in a free of cost to the private sector as well. So the next pillar for this eradication NTB strategy is to treat the intensive phase of 8 weeks is necessary if they are going to be drug sensitive, and if it is going to be resistant, it requires around a month of duration of 9 months in the revised strategy. And the Nikshay Poshak Yojana is a scheme launched by the government of India. It provides 500 rupees for each of the TB patients per month for for procuring more nourished food for his during the taking of the treatment. So India government is providing for each of the patient this moratorium, and expanding the options for ICT based treatment, information technology based treatment. Other and support mechanism is also incorporated in if the patient is been monitoring for the if the patient is taking the treatment properly in the correct duration or not. So IT based system also has been incorporated in monitoring these patients, and the prevention is the Central TB Division is advocating the airborne control measures and contact tracing, and starting the isoniazid preventive therapy. The contacts of the patients infected with TB also are been advised to take this isoniazid for preventive therapy. And better vaccination and addressing social determinants are also other initiatives which can lead to prevent. And this has been the active goal incorporated into this NTP pillar, one of the NTEP pillars. So next, the important pillar is to build and strengthen the enabling policies and empowering the institutions and the lab throughout the India, and improve the human resources with enhanced capacities to handle the recently um, researched and brought out approved methods for diagnosing TB. So this empowering the other all the institutions which are handling for the diagnosis of TB is also another important aspect which is required for correctly and early diagnosing this TB, and to find out whether the drug is the bacteria is responding to the particular drug or not. So the correct drug sensitivity testing is also very important for correct starting the right treatment for patients. That is an important factor which is required, and so this empowering and research building capacity is also being incorporated. In fact, our center caters to this research enhancement, resources enhancements, by which we give training to and continuous training and monitoring is being provided to all the TB labs throughout the country. So we cater to around 8 states in India, and similarly, the other labs which are being labeled as intermediate reference lab in throughout the it is present in every other state in the in India. So these IRLs are responsible for training the other laboratory persons up to the level of primary health centers. So these are the main pillars by which we aim to see a light to achieving towards the goal called NTB strategy. So by this slide, I end my talk, and this is the team which we do our research, phase-based research, and other research related to TB diagnosis. And I will again I thank the committee and Professor Madhivanan for granting me this opportunity to present and be with you during this day in 16th May. Thank you. Thank you.
Thank you, Dr. Hanskar Dastagir, for your wonderful lecture on the tuberculosis and update. And you have taken pain to get us a lot of information about TB and diagnosis and also treatment procedures. So really, it was wonderful in terms of understanding the holistic way of the tuberculosis menace, and also how to manage the tuberculosis burden globally. It is very, very alarming, the situation in which the tuberculosis is infecting the human being, not only in our country, all over the world. So we